All right, today we are diving into one of the most classic and honestly most versatile ways to weld, oxyacetylene. We're going to look at the incredible power you can get from that flame, but more importantly, we're going to talk about the discipline it takes to use it safely and to use it well.
First up, let's just try to wrap our heads around the energy we're dealing with. The flame from an oxyacetylene torch burns at over 3,000 degrees Celsius. To put that in perspective, that is literally more than half the temperature of the surface of the sun. It's hot enough to turn solid steel into a liquid puddle. So we're not just talking about heat here, we're talking about a seriously focused and controllable power source. So here's how we're going to break it all down. First, we'll talk more about that 3,000-degree flame. Then we get to the absolute non-negotiables, the golden rules of safety. After that, we'll get familiar with the equipment piece by piece, run through a pre-weld checklist, and wrap up with how to master those gas pressures.
Okay, so what is actually going on inside that super hot flame? Understanding the chemistry behind it is really the first step to being able to control it.
At its heart, oxyacetylene welding is pretty simple chemistry. You take a fuel gas, in this case acetylene, and you basically supercharge it with pure oxygen. It's that specific combination that creates this incredibly intense flame you need to weld, cut, and even shape metal.
But you might be wondering, how does this flame stack up against something like an electric arc? Well, while it's unbelievably hot, the heat itself is a little less concentrated. This means the metal cools down more slowly, and that can introduce stress into the weld, which can cause it to warp or bend as it settles. It's a fantastic tool for sure, but that's one of the unique challenges you've got to manage. And now we've reached the most important part of this whole explainer. I want you to think of this not as just some list of rules, but as the fundamental code of conduct for anyone who wants to call themselves a welder. When you're dealing with this much power, safety has to be everything. Your safety starts with what you're wearing, your personal armor. Of course, you need goggles to shield your eyes from that intense light, and flame-resistant gloves and clothing to protect you from sparks. But look at what not to wear. Frayed clothing can catch a spark in an instant, and carrying a lighter in your pocket, it seems obvious, but it's a critical mistake you just can't afford to make. So once you're protected, your environment needs to be too. Your workspace has to be a no combustible zone. That means get rid of any wood, paper, or plastics nearby. Make sure you have good airflow, and always know exactly where your fire extinguisher is. You have to remember that flame doesn't know the difference between your workpiece and a piece of cardboard on the floor. Now let's talk about the cylinders. These are high-pressure tanks, and they demand your respect. They absolutely must be kept upright and securely chained down. And why is that so important? Because if a cylinder falls over and that valve gets knocked off, it can literally become an unguided missile. This isn't a suggestion. Careful handling is mandatory. Okay, listen to this. This is a critical warning taken straight out of the safety manuals. Oil or grease is easily ignited and burns violently in the presence of oxygen. This is exactly why you never ever put any kind of lubricant on oxygen fittings. In a pure oxygen environment, even a tiny bit of grease isn't a lubricant, it's an explosive. All right, now that we have our safety mindset firmly locked in place, let's get familiar with the tools themselves. Knowing the anatomy of your welding rig is absolutely key to using it the right way. So you're going to be working with two very different cylinders. The oxygen is usually in a tall black cylinder, and the acetylene is in a shorter maroon one. But here's the really clever safety feature, the connections. Oxygen uses a standard right-hand thread, righty-tighty, but acetylene uses a left-hand thread. This simple bit of design makes it physically impossible to mix up the regulators. It's brilliant. So coming off the cylinders, we have the regulators that control the gas flow, and then the color-coded hoses. It's always green for oxygen, red for acetylene. And inside, you've got flashback arresters. These are critical safety devices that stop a flame from accidentally traveling back up the hoses into the tank. It all comes together at the torch, where you can attach all sorts of different tips for whatever job you're doing. Okay, so we know the risks, and we know the parts. Now, let's put it all together. I want you to think of this not just as assembly, but as a ritual. A critical, step-by-step ritual for safety and for a good weld. The order here is everything. First, secure those cylinders. Next, you crack the valves. That's just a quick, sharp open and close to blow any dust out of the opening. Then you attach the right regulators, remembering those opposite threads we talked about, connect your hoses, and finally pick the right tip for the thickness of the metal you're working on. So, your rig is all put together, Everything feels tight. But how can you be sure there aren't any tiny, invisible gas leaks? This is one of the most important safety checks you will ever perform. And the answer is non-negotiable. Let me be perfectly clear. You never use a flame to check for leaks. Ever. The only safe way is to pressurize the system and then brush or spray a soapy water solution onto every single connection. If you see bubbles forming, you have a leak, and it has to be fixed before you even think about striking an arc. Okay, you're assembled, you're leak-free. Now for the final step before we light this thing up. Setting your working pressures. This is all about being in control. Now, there are some very strict rules when it comes to pressure, and the most critical one is for acetylene. It becomes unstable at high pressure, so you never ever use it above 15 psig, that's pounds per square inch. On the other hand, the oxygen cylinder valve should be opened all the way when you're using it. Remember that contrast? It's absolutely key to operating safely. You have to follow this sequence exactly. Before you open any cylinder, make sure the regulator keys are backed all the way out so they're loose. Then you slowly open the acetylene valve, but no more than one full turn. Next, you slowly open the oxygen valve all the way. Only then do you turn the regulator keys in to set your working pressures. Every single step here needs to be slow and deliberate. You see, in the end, using an oxyacetylene rig isn't just a task, it's a discipline. It demands that you respect the power you're holding, that you master the procedures until they become second nature, and that you prioritize safety above all else in every single thing you do. This tool gives you the power to literally fuse metal together, to create something new and strong and permanent. That power is right there.